Today we're going to look at viruses in our Chapter 10 slides. So we want to go ahead and log in to Google Classroom. You can find it by scrolling through the stream here or by going by category in the classwork section. I'm going to press the up arrow, find my slides. As always, press the square arrow. If you don't do this, I reserve the right to give you a 0 or to just take off points because it's really frustrating for you to work on a PDF, but also for me to grade and comment. So please push that square arrow. So if you're following my pacing, Friday we should have taken notes. They're very easy. Today we should be doing the last slide for Chapter 10. So I'm going to go back, split screen with Google Classroom so I can press X down, and the top red document is the textbook pages so I can look at the book pages. All right, so here we have the virus section. It starts right here. And the first question, how many viruses fit in a drop of blood and how many exist? Those are numbers, so look for numbers. Biological functions are viruses are incapable of. Basically, are they living? There's many. And then we go to shapes again. In this case, the shapes are nice English words. Crystal, sphere, cylinder, and spacecraft is an interesting name. I want you to name a disease of that shape. So if you just read, there are example diseases of each shape. That's not too hard. How is the lytic cycle different from the lysogenic cycle? So this is the lytic cycle, and you have to read below to learn about the lysogenic cycle. The lytic cycle is the normal pathway of viruses, and the lysogenic cycle is different. And if that's all you say, then you haven't answered the question, if all you do is repeat me. What can trigger the lysogenic cycle to produce viruses? The ticking time bomb paragraph is there. I'm going to post this video on the blog so that you can watch it if you finish early. But after we finish, we have something else to prepare for that I'm going to spend some time talking about. And that is the contamination lab. I haven't loaded it in Google Classroom yet, but you're going to be with 3 people, maybe 2, maybe 4, it depends on class sizes. And we are going to use petri dishes to survey the school for bacteria. These petri dishes come in 4 sections. You get to choose what 3 of the sections will be. So you will choose a sample. Then there's the 4th section, that's the control. And later on, we'll figure out what happened. With petri dishes, the bacteria and other microbes floating in the air or on surfaces can end up in the petri dishes and grow into visible colonies. So even though they're microscopic, we can eventually see them. Today I will send one group member home with a petri dish, and they're going to get an air sample. So that's going to happen today. If hybrid students want to participate in a group of students who are at school, then they're going to need to zoom in. There's no way around that. If you don't zoom in, instead of doing a group project, you're going to work alone. So, hybrids, that's up to you. Folks who are here, great. You're going to work together in a group of 3, and since there are 3 choices for where we can sample, then you'll each get a choice. We're also going to sample the air in the classroom, and someone's going to take it home, a little petri dish home, to sample the air there. So that's different. Look for more information in Google Classroom and on my website. But that's we're going to run things a little differently than I've done in the past because of COVID. And so I'm not entirely sure how this is going to look, but I do know that when we use petri dishes, it takes them several days to grow. So by Thursday, we probably won't have enough growth. So we're going to be looking at next Monday, wrapping this lab up and seeing what has grown. All right, I hope to see you, whether that's in person or in Zoom, and good luck this week.